Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve linear static analysis of bracket. The corner angle bracket as shown in below, the upper left hand pinhole is constrained around its entire circumference and a taper pressure load is applied to the bottom and lower right pinhole. Here taper load we have applied, instead of taper load we are going to apply a constant pressure here. Compute maximum displacement and von Mises stress. This model is in inches and Young's modulus also in pound per inch square and pressure in LB. We'll apply the maximum pressure and thickness they have mentioned 0.5 inch. Okay, so we'll analyze this model using the same dimension. Now just open salome meca. Salome meca and code aster is a unitless. Whatever the unit you are using from geometry, the same unit has to be followed. If you are using SI unit means you have to use SI, meter, Newton per meter square, radian per second. That way we have to use. If you are using MKS unit system means we have to use the same unit system in everywhere. Now our model are in MKS, so just use the same unit system. Now just go to geometry model. Now we'll model this sketch using salome. We'll start from here. Go to new entity, basic, option called 2D sketch. So just initially just absolute, just apply it. Next, relative, this length is 6 inch. In x direction, you just switch off this axis. This is, make it 6, fit screen, just apply. Next one is 4, in y direction. We are in the relative coordinate, only the value we need to specify, in minus y, minus 4, just apply. Next we need to create a semicircle of radius 1 inch. So circle radius, this is 1, x has to be reduced to minus 2, this is 1, relative, this is 1, minus 2, make it reverse, yeah. So this is the circle we want, just apply it. Now again change into line, point, relative. Now go here. Now we are in this position, we need to draw this line. As we know, this length is 2, this total length is 4, we are now here. So height of 2 we need to draw 2. Just apply. Now again make it 0. This line we need to draw. So from total length of 6 reduce to 4, minus 4. Move this window here, yeah, just apply it. Now again we need to draw a semicircle. Go to arc. It is automatically connecting, it is closing the line. Sketch closer we can use. So straight line it is connected. We cannot edit actually. Go to line, basic, 2D sketch, absolute, just apply it, arc, radius. From here I just going to draw relative, x is 0, y is 2, radius is 1. Make it reverse. It is going positive, minus y. So switch off this. Yes, just apply, close. Now we need to remove this line. Now we'll build the face. Okay, so select the first sketch, go to new entity, build, face, apply. Actually this is a single arc, so we need to connect the line with that line, this one and this one. Just apply and close it. Now select both the build, face. Now we have done. Now we'll fuse both the faces. Go to operation, boolean, fuse. So mistakenly I have closed with a straight line, so because of that I have done 2 extra operations. Now we have done this. We'll save this file, code aster, bracket, save it. Next one is we just want to create a hole here. For that, go to new entity, point, first point in y direction, -1. Just apply. Second one is, this is the length of 5, here 4, x is 5, y is -4. Yes, just apply and close. Now we have created the point. Based on this point we will create one circle. Go to new entity, basic, circle, use the vertex to about OZ, radius we need to specify as 0.4. Just apply. Similarly you do here, this point OZ, apply and close. Now we'll build face to this. Now we have created the face. Now we'll cut this face from the main face. Boolean, cut. Main object is fuse 1. Tool objects are phase 3 and phase 4. Apply and close. So this is my final model. Now there is one more option is called a radius of 0.4 round has to be done here. To avoid this stress concentration here, in 2D fillet, we have to go for 2D fillet. Planar face is a cut we have to choose. Vertex, this vertex, radius is 0.4. Just apply and close. Now we have created the fillet here. Now we'll save this file. Now we'll create a groups to apply the boundary condition. Right click, create a group, edge group. Here I need to fix it. Just apply. This is showing complete edge actually. The thing is we need to apply only the bottom edges. For that what we need to do? We need to divide. So this is we need to create a plane. Go to new entity, basic. There is an option called plane. Use this edge. Plane, just create a plane of 5 size. Just apply and close. It will create a simple plane. Now select this fillet 2D one. Go to operation, partition, select the plane, apply and close. Now you can see we can get the edge. Similarly, we can use the same geometry for extrusion. Actually, our geometry is 3D. Here we see thickness is 0.5 they have given. So select this partition 1, go for here, generation, extrusion, OZ, thickness is 0.5 they have given. So just give 0.5. Just apply and close. See, we got this one. Now we will create a groups to apply the boundary condition. This complete face we have to apply, we have to fix it. And here the bottom face we need to apply the pressure. Yes. Now we can go for mesh model to create the mesh. Select this extrusion one, mesh, create mesh, region 1D, 2D, 3D, simple parameters 0.05, OK, apply and close, compute. If mesh size is small, if we are getting very fine mesh, we can modify the mesh by increasing the element size. Yes, it seems it's coming 6 lakhs elements. This is a very fine mesh. So we can reduce the edit mesh. Now we can go for clear and compute. This is actually a very coarse mesh. Edit mesh. This is enough it seems. Now we can go for checking the groups. This one is the fix. We need to fix it. And here we need to apply the pressure. Now just go to aster study to create the setup. Here we need to fix it. Here we need to apply the pressure. Okay. And this is a simple case. We can use the wizard to create the setup. Go to add a stage with assistant. There is an option called isotropic linear elasticity. Next, 3D. Here we need to specify the Young's modulus in pound per inch square. 30 into 10 power 6. E power 6. Partition ratio doesn't have any unit. Partition ratio is 0.27. Okay, next. Fix, we need to arrest all the degree of freedom. Then pressure on the mesh group. Pressure. This pressure value is 500 lb. Just specify 500. Just save it. Go to picture, bracket, result.rmed, finish the size. As this will generate only the displacement. This will solve and save the displacement. If you want to see directional stresses and one meter stresses, we need to calculate by using post processing. Go to post processing, call champ. There is an option called reuse the input object. Here use this constraint to calculate sigma element. Sigma node is nothing but directional stresses. Here criteria, here we can choose equivalent element. S means stress node. Reaction force also we can get it as area of interest is not there. The area of interest is not the reaction force. Then leave it. Just apply it. Save OK. Now just modify the output file. Save OK. Just apply and OK. Now we are done creating the setup for solving. Now we will solve the case. Go to history view. Click this plus button. Make it this 5 seconds. Run the case. This is simple linear static analysis. I hope this will not show any error. If any error comes, we have to modify it by reading the error message. Now it is solved without any error. Now we'll go for paraview to do the post processing. Two things we have to look at. One is displacement, another one is stress, especially one is stress. Pictures, code aster. Our case is bracket. Open the result RMD file. This is our model. Here choose displacement. Now check the deformation. Go to wrap by vector. Give some scale factor, then apply it. Now it is bending what we have expected. The only thing is the engineer has to decide the result is correct or not. Otherwise it will give some result. So it is deformation and our applied load and constraint are correct. Now we can check with the stress value. So this one is the 1 V stress. We are getting around 4000. This is just a study case. Now we can go for weaving the result in blue to red. This pattern we can make it into 12 wavy result. We can get it like ANSYS. Now we can animate this also. Just OK. By looping it, we can animate continuously. So this is the way we can animate, we can view the results. Thank you for watching my videos. Please subscribe my channel for code aster related more videos. Thank you.